We have a chapter which name is a set. This is the first chapter, first lecture you can say, first lecture of a class 11th. And that also we will be covering this lecture. Whatever will be important, whatever will be those important points will be covered. Together we will cover. Okay. There are a lot of discussion. There are a lot of topics, a lot of questions as well. One by one we will say. Let's start with this. Now we have introduction. The concept of a set. The concept of a set. Hold on. The concept of a set serves a fundamental part of the hold on. It's working. Here, the concept of we are starting with a definition of a set. The concept of a set serves a fundamental part of the present day mathematics. Present day mathematics. It is saying that a set is a fundamental part. Whatever we are studying mathematics uh, in our life, set is a just a part. Set is just a part concept of the mathematics that we are using in our daily life. Today, this concept is being used in almost every branch of mathematics. Whatever you will take a branch of mathematics, you will observe this set chapter in those branch of mathematics. This is what this second sentence is saying. It is saying today we can observe concept of a set which is being used in the branch of mathematics. Sets are used to define the concepts of relation and functions. First of all, we will be crystal clear about these sets, then relation will come, then function will come. So it is saying, first of all, before we understand relation, function, set will be important to understand it. Then we will be able to understand what is a relation, what is a function. First of all, this is a fundamental for this. This is set is a fundamental for understanding relation and function. Sets are used to define. You will see connection of a set with a relation, connection of a relation with a function. You will observe, don't worry. Okay, now uh, we are done. Next we have the study, the study of geometry. Okay, geometry. You know, this is a separate chapter. Uh, Sequence. Okay, probability. It is also separate chapter. It requires the knowledge of sets. If you take a topic which, if you take a chapter which name is geometry, a sequence, probability, all this will will have what set concept. So now you can understand why should we study this chapter, this set chapter. We should study this chapter because of we can gain information, we can gain knowledge as a student. Second point is that connection of these concepts is with this chapter, geometry chapter, with the second chapter, with sequence, with the probability chapter. And we know that sets, especially shades, will be used to define concepts of relation as well as function. So there are a lot of uses of a set concept. Now we are going to see what is the meaning of a set, what is the actual meaning of a set, and how to represent the set. What is the symbol of representing set? All this we are going to explore right now. Now here we have set, representation of set. This we will cover this two sets. Okay, we will cover this two sets. First of all set, then a representation of a sets. Now here a set is a well-defined collection of objects. Well-defined means right defined collection of objects. We will have a lot of things which will be collection. which will be collection of something. We will take a collection of something which will be well defined, which will be valid, you can say, which will be valid. All those objects will be valid. A collection of something will be valid. If this is happening, then we can say that collection of objects is a set. Is a set. It is a statement. How to convert this statement into mathematics? You will see. How to note how to. What is meaning of this statement in mathematics? Let me show you. Well defined. Remember this well defined. Valid. Whatever objects are in a set should be valid. Should be valid. Should be defined. Should define. The following points may be noted. Objects, elements, and members of a set are synonyms terms. It can be object, it can be elements, it can be members in a set. Okay. In a set you will say that there are objects, in a set you will say there are elements, in a set you will say there are members. Either you can take object or element or member. It's up to you. Okay, it's up to you. All the time we will observe elements, but it doesn't mean that we will not take object, it doesn't mean that we will not take members. No, during this lecture we will see what we are taking: elements. It is a standard. We are not ignoring objects, members. Okay, it's up to you. If you are taking object, then you can say you have a set of objects. If you are taking members, then you can say I have a I have a set of members. If you have list of something, then you can say you have a list of something. Now, sets are usually denoted by capital letters. Remember, you are saying that this much objects are in set. Then, rather than writing set word, just you can apply this alphabet to represent a set, not to represent a set. Just rather than writing a set word, just you can use this alphabet, a capital alphabet, to for set. It should it should not be a small. Remember, set should not be a small. Next we have the elements of a set are represented by a small letters. Third statement is saying whatever will be elements in a set will be should be represented by a small set, by a small letter. As you can see, A, B, C, X, Y, Z, all these are elements. Here you cannot say A, B, C, X, Y, Z are elements. No, these are sets. A, B, C, X, Y, Z, these are sets. But here a small letters A, B, C, X, Y, Z, these are elements of a set. We are considering this as a set. As elements. If P is an element of a set A, P is element, which means in a set there is a one element which is P. Now we say that P belongs to A because P is in set A. P is in set A. That's why we can say P belongs to set A. P, as you say that I belongs to this area, I belongs to this country. Same here, P is belonging to a particular set. Like that you can say. You can say that P belongs to A. You can say. Now the Greek symbol, this symbol is used to represent belong. This symbol is used to represent belong, epsilon. The Greek symbol is used to denote the phrase belongs to. Remember, this symbol will be used to represent belongs to. Okay, this is symbol just a, not completely, but it will look like a. Now, thus we write P belongs to A rather than saying it is in a statement. And now this is in mathematics. You can see how we say that in a statement something and how we convert a statement into mathematics. Here you can see we used a symbol. Now it converted into mathematics. We are saying P belongs to A. P belongs to A. Here, if P is not an element of a set A, if P is not in set A, then just you can say P does not belong to A, just a slash. Here we write P does not belong to A. Read P does not belong to A. Okay, we now note the element of a set. The elements of a set may be listed in any order. In any order, we will see. So in this slide we understood we understood meaning of a set. We understood what is object, what is element. So elements are in a set. Elements is just a collection. We understood uh, how to write a set. How to write a set by capital. We understood what should be way of writing uh, elements of a set. So a small letter, all elements should be in a set. We understood what belongs to what. We understood this. So we understood P belongs to A, which means P is element and A is a set. P is in a set, and this we are saying this into another sentence. We are saying P belongs to A. This is what we are saying. Okay, we understood what if there is no element in a set, then what will we say? Then we will say that this does not belong to this set. This element does not belong to this set. That's all we understood in this slide. Now we are moving to next slide. In this examples we are taking the collection of vowels in a English alphabet. Vowels. The collection of vowels in English alphabet. In English alphabet. So in English alphabet we have five vowels. Five vowels: A, E, I, O, U. Five vowels. Now this is a collection of this five vowels is a collection of vowels. Now how to write it as a set? Just we will write a set then is equal to, and remember set is represented by curly brackets. All elements are surrounded by curly brackets. Remember. So set then is equal to, then curly brackets, then all five vowels A, E, I, O, and we write each element by applying comma A, E, I, O, U. Then close curly brackets. That's it. This is how we convert this sentence into mathematics, into set. Here you can see. This set contains five elements, yes, because vowels are five in an English alphabet, namely E, A, I, O, U. We know. Now next we have the collection of first five prime numbers. Prime number starts from 2, then 4, then 6, then 8, and we should have 5. 10. 2 5 are 10. 2 3 prime numbers, not even numbers. Okay, prime numbers. So 2 3 5 7 11, these are prime numbers. So we can say the collection of first prime numbers. Okay, next the collection of all states, the collection of all states in the Indian Union. Indian Union. So we have 29 states, isn't it? Is a set. We have 29 states or 28 states. So this is a collection of all states of India country. This is in this is in this is a statement. We can convert it into mathematics. We will see. Don't worry. Now next we have an example which is the collection of past, present presidents of the Indian Union is a set. Past presidents, not present. So this is also, this would be also, whatever is a collection of a something will be a set. Will be a set. Whatever is a collection of a something will be considered as a set. Now next we have a set, the collection of cricketers, the collection of a cricketer who play. So the collection of cricketers in the world who were out 499 runs in a test match is a set. So we are taking collection of cricketers in the world who were out 499 runs. Next we have the collection of a good cricketer players of India in not a set. Since the term good player is vague and it is not well defined. The collection of good cricket players. Okay, this is not a set because good player is a vague and it is not well defined. Concept test. Ready for challenge? Here we have questions. Question. If this A is a set, in this set we have how much? 11 elements. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. From here to till here, this is a 10 and 0, one more, 11 element. Then insert the approximate symbol, this symbol, or does not belong in each of the blank spaces. So we have 4. So of course 4, there is a 4 element, or in this we can say 4 belongs to A. We can say because 4 is in this element. So 4 belongs to A. Answer would be 4 belongs to A. Second we have -4. So -4, where is the -4 in this? In this is it. No, it does not belong to A. So here this is simple, does not belong to 12. No. 12 is also not here in this set. So 12 does not belong to A. 9 belongs to A. Here. Yes, 4 belongs to A. No. Yes. Next we have question again. Which of the following collection are sets? Collection are sets. A collection of all natural number less than 50. It is a set. We know, because here we have a collection of all natural number, but it should be less than 50. So it is also considered as a finite set. We will see what is a finite set later. What is a finite set. So here we have natural number and it is a less than 50. So of course we will have how much? 49 elements. 49. So can we say that yes, it is a set? Yes, we can say, because we have a collection of all natural numbers. Now next we have, so here this is a collection, this is a set. The collection of a good hockey, we saw that good is not well defined, so that's why this will not be set. The collection of all girls of your class, I think it should be all girls of your class. So It is a set. The collection of difficult topics in mathematics. So I think it should not be set difficult topics. Let's say yes. This set have all natural numbers from yes, no, because good, because there is no specify criteria to determine whether a hockey player is good or not. So the collection of good hockey players. Okay, difficult topics. So it would be yes, difficult topics. Yes, there the set have all girls of your group. No, because there is no specified criteria to determine whether a topic in mathematics is difficult or not. So here we have the collection of difficult topics. This was no. No, because there is no specified criteria to determine whether a topic in a mathematics is difficult or not. Set used particularly in mathematics. In okay, you will see a lot of times this in, which stands for the set of all natural number. It is used to represent natural numbers. So whenever we are using this in set, then sometimes you will be saying that n such that this set of all natural numbers. W, which means whole number. So here you are saying the set of whole numbers which starts from 0. The set of whole numbers z, or I, it is an integer. So can we say the set of all integer numbers, now z plus, which means only positive integer, positive, which will start from 0, so finally we have got this set of all positive integers. Q, I think it should be rational. This set of all rational numbers. We know that first letter of a rational is R, but why here is a Q? I don't know. It was said that Q will be presentation of a rational number. So we are using this Q word, Q letter for rational number. So Q is a set of rational numbers. Q plus, so I think what? The set of a positive rational number. Okay. When it comes to only Q, then of course we can have a negative rational number, we can have a positive rational number. So if we are using plus, then here we are saying we have what? Positive rational number. This is what we are saying by using this symbol above the Q. Now next R, only R real. So why did we not write here R for rational? Because we got R two times, so that's why rather than using R letter for this, we used what? Q, so that we cannot get confused. So Q, here R is for real number, R is for real number. So here the set of all real numbers is R plus. Okay. This set of all positive real numbers. This set of all positive real numbers. Next, representation of sets. Let's see. I think curly brackets. Roster. Okay, representation of so sets. Roster form or tabular form, or and set builder. We have two form. one roster form, and second is a set builder form. Set builder form. Both are different, but remember, meaning would be same. It is a statement. It is a directly mathematic. It is a statement. It is a directly mathematic. You will be able to understand what is it saying, and you will have to understand what is it saying. It will be invisible and it will be visual. Let's explore it. Here we have a roster of a tabular form. We are understanding what is the meaning of roster form. All the elements of a set are listed. Okay, are listed. All the elements of a set are listed. The elements are being separated by comma. By comma. Okay, A element, then comma we will apply, then again B, then again comma. That is how we represent elements in the set, and are closed within brackets, and this bracket is known as curly brackets. We will not use all those brackets except this. No, we will only use this bracket only this bracket, nothing else, nothing else. So remember what is the meaning of roster form? Meaning of this is what all elements we write by separating what comma, and then we use curly brackets, open bracket, close bracket. Starting would be open bracket and ending would be close bracket. Examples, we have this set of vowels of English alphabet. This is not in roster form. Remember, roster form would be what? A is equal to curly brackets, then vowels A, E, I, O, U, then closed bracket. This would be roster form. You can see here. Can be described as A, E, I, O, U. This is roster form. It is not. As you know that this is a statement. And now here from here you can say this is roster form and this is statement. As I told you that set builder form is just a statement, and this would be statement. This statement is a set builder form. Set builder form. Now here try to understand. So this here meaning of this and meaning of this are both different? No, both are same. In the term of in the order to saying meaning, both meaning of both are same. Just we are writing something into different way. Here you can see this is a visual directly. It is in mathematics. Here this is a statement which is in English language. It is in mathematic language. Both are different in writing way, but meaning of both are same. Meaning of both are same. Now the set of even natural numbers. This is set builder form, because this set of even natural number is a statement. That's why. Now here, just read it carefully. This set of even natural number. We will take natural number, but only even. We will ignore odd number. So let's take a natural number. So here we will have infinity natural number. So let's start from 0. 0 would be even. It is not. It is neither. 0 is neither even nor odd. So let's start from 0. From 2. 1 is odd. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. All these are even numbers, and it will keep going on. It will keep going till the infinity. There is no end. So all these are what? Natural numbers, even natural numbers. It can be described, it can be represented as how? Open bracket, open curly bracket, then 2 4 6 8, then infinity. I think infinity. That's here. This comma is representing that it is a infinity. This comma is representing. Here it started from 2. 0 is not odd or even. Even will start from 2 and odd will start from 1. Now next we have here the dots stand for and so on. So this will keep going. Here we are saying 2 4 6 and so on, like that we are saying. So next set builder form. It's a time of a set builder form. All the elements of a set possess a single comma property which is not possessed by any element outside the set. Something teeny will be different from this statement. Teeny. All the elements of a set possess a single comma property which is not possessed by any element outside the set. Let's understand this with the example. Here x what single comma property x such that px holds. Here we have x such that px holds. This is what is set builder. Here meaning of this set builder form is that which is read as this set of all x such that px hold. This will be unreadable, but this tabular form will be readable. You will have to understand this set builder form. Here the symbol this or is read as such that x such that px holds. Such that px holds. Example we have this set A. With the real example we are understanding. This set A, in this set we have 8 elements. Okay, 8 elements. Now this is what? This is a set roster form. This is in a roster form. Because we wrote all elements by separating comma and by surrounding, by using what? By applying curly brackets. So here it can be converted into set builder form like that. It is in set builder form. Meaning of this both are same. Meaning of this and this both are same. Just it is in tabular form and it is in set builder form. Importance of both are what? In their way. Here A is a, let's explore this. Let's break down it. A is a set. This is the name of a set. Is x belongs to A. Whatever will be x will belong to A. N is a natural number. N is a natural number. So here we are saying x belongs to N such that x is what? X is a natural number. We will start a natural number from 1, 2, 3. But remember here 8 till the 8. It is greater or equal to 8. Natural number should be greater to 8 and equal to 8. So 1 2 3 7 1 2 3 4 5 6 7 8, all these are in a set. All these are elements in a set. This is a finite element because we have limited elements. When we don't have limited elements, then those elements will be infinity. But here, as you can see, we have limited elements, that's why it is a finite. In details we will see what is the meaning of what is the discussion of a finite and infinite elements. Right now, right now, did you understand what is it saying? It is saying x belongs to n, and here if we are saying x belongs to a, it means we have a natural number. So we will start taking natural numbers, but where to end? This is main point. Where to end? So we will have to end till the 8. Till the 8. We will take 8 as well. Till the 8. Now next. Concept test. We will have some question will come to us and we will see. So here we have this question: column matching, set builder form, roster form. X belongs to n and x square, then 25 is greater than 25 is greater than. So natural number. So 1 2 3 4, these are natural number. Suppose 4 4 the 16 and 5 5s are 25, but here we should have less than 25. Suppose less than 25 would be what? 4. 4 4 just 16. So this is of this. Now next we have x belongs in natural number. We have natural number such that x is a prime number. So prime number, not even number, prime number. 2 3 5 7 11, all these are prime numbers. So here we will start from 10. Okay, we will start from 10 and less than 20. We will start above the 10 and we will stop below the 20. So 11 11 13 17, all this. So this is for this. All these are in set builder form and all these are in roster form. This is for you. Now next we have again just a project. Next we have here roster form, then set builder form. Let's match it. 3 6 9, we have a 3, we have a table of 3 3 1 is 3 3 2 is 6 3 3 is 9 3 4 is 12. This is a table of 3. Now next we have 1 2 2 is 4 3 3 is 9 4 4 is 6. We have perfect square. Now let's read this. First is saying x square. We have a x numbers, which is a raised to power. So x square such that x belongs to n. We have natural numbers. Now we will start from 1 till we will stop till the 10. And remember, we are taking perfect square. X square is about perfect square. So 1 raised to power 2 would be 1. Then 2 raised to power 2 would be 4. 3 raised to power 3 raised to power 2 would be 9. Suppose this is for this. This is the fourth thing. Now next we have x such that x is equal to 3n. Okay, x such that x is equal to 3n. Here n belongs to z plus. Here z is the integer, but we have z plus, which means positive integer, not positive. Yes, positive integer. So I think natural numbers. Natural numbers. Positive integer is a natural number or whole number. So here, first let's start with the one. With one. 3 ones are 3, then 3 twos are 6, 3 fours are 3 twos are 6, 3 threes are 9. So all these are roster form. So we have what 3, then 3 ones are 3, then 3 twos are 6, then 3 threes are 9, 3 fours are 16, 3 fives are 3 fours 12, 3 fives are 15. It is a complete. Oh, it is a complete. Wow. Now we are done. Let's explore one more chapter. One more chapter. Next we have types of assets. Yeah, this is also important, types of asset. Then we have operation on sets. Both are important. Yeah, both are necessary. But first PPT was very unstable. Please make sure you have active internet connection and try again. Okay, no problem. Again. It didn't work. Yeah, it worked. Finally, it worked. No. Okay, let it open. You can take a break for few seconds. Why it's not opening? So here we have next PPT. So I think you are with me with this discussion. In this PPT, we have types of assets, subsets, and power sets. All those types of assets we will understand in too much details. Now let's start. Types of assets. Directly, I can say without looking at here, I can say that we have infinity sets, singleton set, empty sets, null set. Null set or empty set both are same. Apart from this, there are more. Here, subsets. It started from subset. What is a subset? It is just a piece. It is just a piece of a set of a whole set. What is a subset? Subset is a piece of a set. It can be defined in other words. Okay, subset can be defined in other words. Power set, we have two sets. Right now we have two sets, subsets, power set. So first types of sets. First empty sets, then next singleton set, finite set, infinite set, finite set, infinite set, then equivalent set, equal set. Okay, these are we have these much types of sets. Then after completing this, we will have power set. Okay, after completing these types of sets, I can say what is the empty set? A set which does not have any element. Okay, any element. This set has nothing. This set has nothing. A set which has nothing, only curly brackets. So this set will be empty set. Let's see what will it say. It is saying I am fan of this PPT because it was made very understandable for a student. Here we are. A set is a set to be empty or null or void set if it has no element. And directly we in one sentence we can directly say that a set does not have element will be empty set. Did you understand? No elements, no elements, only curly brackets. It is denoted by this phi. It is denoted by phi. How to pronounce it? Don't worry. Phi. This will be also null. Either you can call it as null or empty. It's up to you. This is your choice. Either you can say that yes, this is empty, or you can say that this is a phi, or you can say that this is a null. Meaning of both, meaning of three, this is the same. Here, a set A is an empty set if if the statement x belongs to A is not true for any x. This would be, it is in a set builder form. If the statement x belongs to A is not true for any x, this is in set builder form. It was just a statement which is a sentence. Now we have x belongs to R such that R is what? Real number. Now x square is equal to -2. So of course it does not exist. I think so. it does not exist. That's why this will be empty set. Here, the set A given by A x such that x is an even prime number greater than 2 is an empty set because 2 is the only even prime number. It is not a square root of a perfect square. If we put here x, then what will we get? Of course 1. If we put here 2, then of course we will get 4, not minus 2. So here we are saying we don't have any elements in this set builder form. Now next we have singleton set. Singleton set, which means one element. In a set has only one element is a singleton set. Single, one element. So in one sentence you can define it as that this any set which has only one element will be singleton set. Which type of set? Singleton set. Here a set consisting of a single element is called a singleton set. With example, let's try to understand it. This set 5 is a singleton set. It is saying in a set there is a one element which is a 5. There is a one element which is a 5. Only one element. Then this set will be singleton set. Now next, this set x belongs to x such that x belongs to natural number and x square. So we will start from 1 raised to power 2 will be, and it is 9. It is equal to 9. It is equal to 9. So 1 raised to power 2 is not equal to 9. Here 3 raised to power 2 will be equal to 9. So 3 is an element. 3 is an element. All the elements will be considered as x. Now here 3 is only one element in this. Clear? So this type of a set will be singleton set. Now next we have finite set. Any set you are taking, you have any kind of a set. If you have limited sets, you are able to count those elements will be finite set. Only you should be able to count those sets, then you can say that yeah, you have a finite set. For example, a set which is empty or consists of a definite number of elements is called definite. Set of even natural numbers. But here we are saying less than 100. It is now limited. It is fixed. How much? From 1 to 99. Only from here natural numbers. From here to till here natural numbers. It will be what? It will be infinite elements. But here ahead of this we have what? Less than 100. It is telling that you have this much elements. You have fixed element. So this limited will be finite set. This type of a set will be finite set. Whenever somebody is saying that you have a finite set, it means you were given a set which has counted sets, which can be counted elements in a set. Now next, cardinal number of a finite set. The number of elements in a finite set is called the number of elements in a finite set is called cardinal or order of a finite set. Okay. number of elements. Let's say there are six numbers of elements in a set, so six number of elements will be cardinal number, and here it will be denoted by n. N is not natural, this is a small. For representing natural we will write capital N. So here a small n is representing about numbers of elements in a set. A is a set. Here by representing like that we are saying number of elements which is in this set are this much, is this much. So in this we understood what is a finite set, as well as we saw what is a cardinal number. We understood that number of elements. Now infinite. Infinite, it is directly saying to you that yes, I have infinite. There is no end. It will keep going. You cannot be able to count the elements. That is what it is. Infinite set is saying to you. Let's see. A non-empty set. We don't have empty set. Non-empty set, which means we have something. A set has something. A set has something. This is the meaning of a non-empty set. A non-empty set which is not a finite set. Yes, this will not have fixed number. This will not have fixed elements. This will not have limited elements. Infinite set has unlimited. It has infinite number of elements. Clear? A set whose elements can be listed by natural numbers 1 2 3 dash 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 dot 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 n. For any natural number n is called what? An infinite set. N is what? Number, natural number, no, number of elements. Set of all points in a plane, all point. We don't know how much points are in a plane. Set of all lines in a plane. Even right now we don't know what is the number of what are numbers of all lines in a plane. Third, which is in a set vector form, x belongs to R such that 0 we will start from 1. Okay, then before the 1, what is it saying? Real number. Of course here we will take a rational number. Okay, rational number. So rational number is an infinity number. Rational number between 0 and 1, there are a lot of rational number. So this is what this is a infinity. This is a collection of infinity rational number. So this is a set. Which type of set? Infinite set. Now next, equivalent set. There would be twist between equivalent and equal. There would be one twist. You will have to see carefully. We are starting with this. Two finite sets. Okay, A and B are equivalent. If their cardinal number of number of elements. Remember, in this we will see what number of elements. Okay, if one set has number of elements are 4. Okay, number of elements of a set has a 4. Same in another set, number of elements are 4. So this both will be equivalent set. Here our focus will be on number of elements in two sets. Clear? Number of elements, cardinal number. So here number of elements of this set would be equal to number of elements of this set. This is what is the meaning of equivalent sets. Here we take two sets. Here we take two sets. Next example, with example try to understand here. We have this set 1 2 3. In this we have 3 number of elements, we have 3. In this we have 3 elements, 1 2 3. Here our focus is on number of elements, so both are numbers in and in both are same, so that's why this both will be equivalent sets. So you can write it as like that, this is equal to this, this is equal to this, equal set. Here I think so our focus would be on same elements in both sets. Our focus concentration will not be on number of elements in both sets, no. This was an equivalent set discussion. Now in the case of a equal set, we will see what are the all elements present, are all elements of a set present in other set. If yes, then this both sets will be equal sets. Let's see, two finite sets A and B are said to be equal if every element of A, every each element of A is a member of B, and every element of B is also a member of A. Here in a set, all elements of a set is also in another set will be equal set, will be equal set. If sets A and B are equal, we write A is equal to B, A is equal to B. Here we are not writing n because we don't need n here. We need members, same members in both sets. If sets A and B are not equal, then just we will apply a slash on equal. Then here we will say that A is not equal to B. Here we are saying in a set, elements in a set are not the same in other set. This is what we are saying by applying slash on this equal. We write A is not equal to B. An example, with example, let's see. If A in this we have 1 2 5 6, same here we can see 1 2 5 6, 1 2 5 6. Whatever are in this element are here also. This would be equal sets. This would be equal sets. So A is equal to B because each element of A is an element of a B, and vice versa. Just opposite. Just opposite. This is done. Not equal sets are equivalent sets. Yes, number of sets. Here we saw that number of elements in this is equal to this. So this will be also equivalent, but we cannot say that equivalent set would be equal set. No, equal set will be equivalent set, but equivalent set will not be, could not be what, equal set. This is what we are saying in this. Equal sets are equivalent sets, but equivalent sets need not be equal sets. We have understood. Example here 1 2 3, and here number of these elements are 3. In this also number of elements in this set are also 3. This is equivalent set, as we saw discussion of equivalent sets. But what about equal set? Can we say that this is equal set? No, we cannot say, because in this we have 1 2 3, but in this we have ABC. Both are different, and equal set does not say this. Equal set that a set, whatever will have a set, will be also same in another set. This is what equal set says. Equal set explains. Now this is a done. Here we are saying number of a and this is equal to, but here a will not be equal to b. Now this is done. Now we have concept test. Let's take some questions. Uh, by taking this question, you will know that yes, you have understood this much. You something didn't understand. By taking this challenge, you will see to yourself. Now we have this match the column. Match the column. Here x, okay, x is such that x is a even prime number. So 2, only 2, 2, only 2. So x is a prime number. So okay, next x such that x square minus 3 is equal to 0 is equal to 0 and x is a rational number. So I think this would be empty. This would be empty, and here we have one element, so this would be non-empty. This is empty. We don't have. If we put a rational number, okay, 1 by 2, 1 by 1, then we are not getting 0. 1 by 2, again we are not getting 0. 1 by 3, again we will not get -3. No. So here we don't have any element in a set of a B. That's why this is matching this is matching this, just opposite. Let's see. Okay, even prime number. So here we have only 2. We know that 2 is the only even prime number, and all except this we have all those numbers are all prime number. Therefore A is, so it is a non-empty. Now next we have uh, okay, here no, we know that there is no rational number whose square is a 3. Yes, whose square is a 3. That's why. So x square minus 3 is not satisfied by any rational number. So that's why there is a no element. So it would be equal to this. B is an empty set. Okay, next. X such that x belongs to z, integer. Okay, integer. Wow. X square minus 5x plus 6 is equal to 0. It should be equal to 0. Should be. If you take here 1, then 1, but not 1. Let's take how much? Let's take this is for you. Let's take here no any number. If yes, -1 -1, then 1 no. So I think and here x is such that x belongs to z, and here z is an integer. X square is even. So 2 is a 4, 3 is a 9. So of course this would be infinite, and this would be finite.